All right, Mr. Ahmed here for 7.5 part 1. Today we're going to work with trapezoids. And our first process is just going to be to identify what a trapezoid is. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So only one pair of opposite sides can be parallel. The other opposite pair of sides will not be parallel. Okay, so that's a trapezoid. So I drew a kind of a funky looking trapezoid just because typically you'll see one drawn more like this, but this is also a trapezoid. It has exactly one pair of parallel sides. These opposite sides are not. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So these are the parallel sides. The non-parallel sides are the other two, so those two are congruent. That makes it a isosceles trapezoid. Okay, so isosceles trapezoids have quite a few special features. The isosceles trapezoid, the base angles are congruent. So what we mean by the base angles is they share one of the parallel sides. So angle B and angle C share the parallel side BC. Those two angles are congruent. And the other pair of base angles, A and D, they share the parallel side AD. They are also congruent. It's usually pretty obvious when you look at the diagram, but there might be some that aren't drawn to scale where it says it's an isosceles trapezoid, and you'll have to recognize this. So angle A is congruent to angle D, and angle B is congruent to angle C. Okay. Also, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So in this diagram, angle A and D are congruent. They're base angles. They share this parallel side. So that means it has to be isosceles, so these two legs would be the same length. Okay? All right, last piece. If the trapezoid's isosceles, then the diagonals are congruent. So that means the whole thing, B to D, is congruent to AC. Okay, so that's just for an isosceles trapezoid, not every single trapezoid. All right, so hopping into some example problems. So the first thing I say, find angle N, L, and M. I see that this is an isosceles trapezoid because the legs are congruent. This is the parallel sides. So since that's the case, I know angle N is 50. Those two are congruent. Now here's the tricky piece. For me to find this one, I have to remember that these are consecutive interior angles. So L and K have to add up to 180 degrees. So 180 minus 50 is 130. And angle M is also 130. So we found our missing angles. Next step. In this trapezoid, find the value of x. A couple things here. At this point, all that I know is that the whole diagonals, these are congruent, okay? It says that it's an isosceles trapezoid, so I just know that from here to here is the same length as here to here. So I would have to say 3x plus 6x minus 5 is equal to 21 plus 5x plus 2. And then we would solve for x. Let's see if we get 7. I feel like it should be 7 because those look like they're the same length. Let's find out. So 9x minus 5 equals 23 plus 5x, combined like terms. Bring our x over. 4x minus 5 equals 23. Add 5, 4x equals 28, and x is indeed equal to 7. So my intuition was correct, but I didn't know that for sure. Mid-segment of any trapezoid. So everything we just focused on now had to do with isosceles trapezoids. This is for any trapezoid. So the mid-segment of a trapezoid is parallel to each base, all right? And its length is 1/2 the sum of the lengths of the bases. So a couple things about the mid-segment. The mid-segment MN, all right, it is going to connect the two non-parallel sides at each one's midpoint. So M is a midpoint, and N is also a midpoint, all right? Those have to be midpoints for the legs, okay? So MN is parallel to AB. It's also parallel to CD. And here's the key. It is equal to 1/2 these sides added together. So the length of AB plus the length of CD. Okay? And we're going to use some mid-segment problems next. So in the diagram, it says MN is the midsegment. Notice M's a midpoint, N's a midpoint. We're supposed to find the length. So it's equal to 1/2 the bases added together. So 16 plus 9. Make sure you follow the order of operations here. 16 plus 9 has to get added together first. That's 25 times 1/2. Half of 25 would be 12.5. And that's in inches. And lastly, we'll set up an equation. So this one's a little bit tougher. So this is indeed a midsegment. I'm told that it's a trapezoid, so these are going to be the parallel sides. All three of these are parallel. So the midsegment, 20, is equal to 1/2 the bases added together. So 17 plus 7x minus 5. I can combine the like terms inside, so I have 1/2 of 17 minus 5. That's 12 plus 7x equals 20. From here, you could distribute the 1/2, or you could multiply both sides by 2. I'm going to distribute the 1/2 because I think that's what most of you will do. So 20. Half of 12 is 6 plus 3.5x. 1/2 of 7 is 3.5. We'll subtract our 6. 14 equals 3.5x. And now we have to take 14 divided by 3.5, and that's 4. All right, that's it for the trapezoids. Have a good one.